All right, so let's finish up talking about the truth table method. Um, its advantages and its disadvantages. And I think it's good to know about the truth table method, but people don't use it very much, and it's not very useful for reasons we'll talk about. It's good to know. And if you're on a test and you just can't figure out any other way to show an argument's valid and you have a lot of patience, well, it will work. That is the first advantage of the truth table method, right? It works. It doesn't involve being very clever. In fact, a computer can do it. And if an argument is invalid, it will tell you why, right? It will show you the circumstances where the premises could be true and the conclusion false. The disadvantages, the main ones are that it is cumbersome and time consuming. It takes a lot of time to draw up a truth table. I am getting very bored with doing it in these slides and will be pretty glad not to do it anymore, right? It is also very, and they get bigger. The number of rows, the number of lines doubles with every proposition. I was going to do one for you guys with 5 propositions, and I couldn't even really get it on my computer screen because everything was so small, because you're getting up to so many rows so quickly, right? You have 5 propositions, you have 32 rows. If you have 6, it's 64. That gets to be very, very hard to work with very quickly. Not only is it time consuming, but because you have to fill everything in, it gets easier and easier to make a mistake. Another problem is if an argument is in fact valid, it often doesn't throw much light on why it's valid. If it's invalid, it tells us a lot about how and why that is. It really doesn't tell us much about exactly how and why a valid argument works. The bigger problem, though, the biggest one, is just that it gets so big so quickly that it's time consuming and a real pain in the neck and easy to mess up. Now, one partial solution, which Smith talks about, is to only fill in the lines where the premises are all true and ignore all the others. This makes the truth table method a little more manageable. Let me give you guys an example of how you might do this, right? Well, look. I'm not even going to give a fake argument, that we're symbolizing here. We'll just start in symbolic form to save time, right? Not P or not Q, Q or R, P and S, so R or P and Q. Is this a valid argument? You guys might be wondering. You might say, I have no idea. Well, let's test for validity using our truth table method. So we set up our truth table, right? It's already going to be a big ungainly thing. We have our 3 premises and then our conclusion. I haven't labeled them, right? Being a little lazy on this one. We're going quick, right? Trying to save time, so let's save time, right? Well, look. If we want to save ourselves effort, think about P and S, right? Let's fill it in first, right? If we're only thinking about lines where all the premises are all true, conclusion's false, well, let's ignore any lines where P and S is false, right? Well, that means we can ignore, we have this big block where S is true of 8 trues and a big block of 8 where it's false. Well, we can just ignore the whole bottom 8 where it's false, not even think about that, not even fill it in. So then we just look at the lines where it's true. Well, since S is true on all these top 8, P is going to be what determines it. So back and forth, TF, 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 right? So we just fill these lines in where P and S is true. Well, then we could just, it doesn't really matter. We might as well fill in Q and R, though. Well, we only need to look at the lines where P and S is true. Well, on this first one, Q and R is true because both Q and R are true. On this second one, well, Q's not true, but R is, so it's true. On this third, R is not true, but Q is, so it's true. On this bottom one, Q and R are both false, so we don't even fill it in, right? Well, now that we've done that, we only need to look at the lines where Q and R are true. We don't need to fill in any others. Well, on the top one, not P or not Q, that's our last premise. Well, P or Q1 has to be false for this to be true. They're both true on the top one, so it's false. We don't even fill it in. Don't even worry about it. Move down to the second one we need to think about. On this one, P is true, but Q is false, so we can fill in a true here. The third one, P is true, Q is true, so it's also false, so we don't even need to fill it in, right? Well, now all we need to think about is this, this one line where not P or not Q is true, Q or R is true, and P and S are true. Is it true or not? Well, we don't even need to think much about it. R is true on this line. If R is true, remember, for this thing to be true, it either has to be true that R is true or this whole other mess is true. We don't need to look at the rest of it because we already satisfy R. We can fill this in as true. The argument is, in fact, a valid argument. Look, this makes the truth table method a little more manageable for long arguments. It's still pretty bad, right? Let's just be honest. It's still bad. It's still not a great way. You have to fill in all this junk for PQRS. Then you have to think about, which lines to fill in. It'll save you a bit of time. It's still not great. Doesn't do a lot to solve the problem. It does a little bit. I don't think this is a good method for determining. Even if we simplify it like this, I still don't like it myself as a way of determining validity. It will work. It's time consuming and it's kind of complicated. So even with this sort of shortcut, for arguments of any real complexity, the truth table method's just not a good method. At least not for human beings. If nothing else works, then, the more methods you have to solve a problem, the better. But generally, it's just not a great one. So there are two other ways of showing that an argument is valid. One of those is the Tableau method, which we'll talk about. It's a bit like the truth table method, but it's much more efficient, much more elegant, I think, and it's much quicker. There's also natural deduction. Natural deduction, if you can get it down, is probably the most efficient of the three and the quickest. It's also really tricky, and a lot of people have trouble with it. If you like this stuff, if you're good at it, if you're into it, natural deduction is worth learning. I'm not going to talk about it as a method because, we only have so much time in class, and I think of the methods, it definitely has its merits, but a lot of people struggle with it. The Tableau method, which we will talk about toward the end of the course, it's not as efficient as natural deduction. It's a lot better than the truth table method, and it's not nearly so hard to master as natural deduction. For me, at least, for this level of class, I think the Tableau method hits a pretty good Goldilocks point, but, a lot of people will prefer natural deduction, which if you go into logic in more detail, you will definitely talk about. It's just, for me, I think the Tableau method makes a little more sense. Anyway, we won't get to that for a few weeks because first, I do want to talk about conditionals. We'll learn about the basic idea of conditionals, and then we'll spend a week just talking more about how to symbolize conditionals because they can be really tricky. Some of the kind of interesting philosophical issues around conditionals, and also some other stuff about translating arguments now that we have everything on the table, or will have everything on the table with conditionals. All right. Anyway, we now have at least one method for determining validity. Not a great one, but it works. In a couple weeks, we'll talk about a much better method for determining validity. But first, I want to talk about conditionals and a bit more on translation.